Assalamualaikum warahmatullahi wabarakatuh. Today we will see some tutorial from chapter 6 on the clutch. So this is previous question from past year question, March 2015, question number 5. So let's look at the question. A 50 kilowatt engine develops 60% from its total power at 1200 revolution per minute and fitted with a cone clutch. So this is a question related to cone clutch, where the cone clutch receive power from engine, which is 50 kilowatt, and then from this 50 kilowatt it only receive 60% at the speed of 1200 revolution per minute. The cone face angle, so given the cone face angle is 12.5 degree with a mean diameter of 400 millimeter. So this is given also the mean diameter of the cone clutch, which is 400 millimeter, and then coefficient of friction for that cone clutch is 0.35, and then allowable normal pressure, so this is P allowable, is not exceed 80 kilopascal. So we assume that allowable normal pressure, which is P allowable, is 80 kilopascal. So by using uniform wear theory, we need to find first the inner and outer diameter of that cone clutch, and then attracting force, which is Fa, required to engage the clutch, and then the face width of the friction lining, which is W, and last, why the semicone angle is frequently designed as 12.5 degree. So give two reason. So now let us put all the information given written at the below first. So first, P1, so given 50 kilowatt, only develop 60%. So I did 30 kilowatt. Yes, given also the speed, which is 1200 revolution per minute, and then the cone face angle, so 12.5 degree. Given also the mean diameter dm, which is 400 millimeter, and then given also the coefficient of friction, which is 0.35, and last normal pressure, which is P, is 80 kilo pascal. So using uniform wear theory, determine inner and outer diameter of clutch. Given the mean diameter dm is 400 millimeter. So from formula of cone clutch, mean diameter is equal to major diameter plus inner diameter divided by 2. So our mean diameter is 400. Major and inner we need to find. So let the same as D and D divided by 2. So simplify, we assume that major diameter, which is D, is equal to 800 minus D. So this one we assume as the first equation. Given also the rotation speed of the cone clutch is N is equal to 1200 revolution per minute. So for rotation, for angular speed, which is 2 pi n over 60, we put the value of the rotational speed, which is 2 times by pi times by 1200 divided by 60. So we get the angular speed is 125.664 radian per second. So power is equal to torque times with the angular speed. We know that. So simplify, we take as torque is equal to power divided by angular speed. So the actual power is 30 kilowatt divided by the angular speed, which is 125.664 radian per second. So we get the value of torque is 238.732 Newton meter. Note that normal pressure allowable is maximum pressure. So from uniform wear cone clutch, which is torque capacity formula, which is torque is equal to pi times by coefficient of friction times with the maximum pressure times with the inner diameter of the cone clutch divided by sin alpha times with d square minus d square. So d for major diameter and inner diameter. So we put the value here. Note that the top value is 238.732 is equal to pi times with the coefficient of friction, which is 0.35, times with the maximum pressure, which is 80 kilopascal, and then we assume just inner diameter, because we need to find that value d. So divided by sin alpha, which our alpha is 12.5 degree, times with the major diameter square minus with inner diameter. So simplify. So inner diameter times with the major diameter square minus inner diameter square is equal to 4.699 power negative 3 meter. So this will assume as the equation number 2. So we sub the equation number 1 into equation number 2. So equation 2, which is d inner times with the d square, the major diameter minus the inner diameter square, is equal to 4.699 power negative 3. So we sub the major diameter d into this. So d inner times with the equation number 1, which is at 100 power negative 3 minus d power of 2 negative d power of 2 also minus 4.699 power of negative 3. So we simplify the equation. So d inner is equal to 0.64 minus with 1.6D plus with the D inner D square minus D inner square is equal to 4.699 power of negative 3. Next, we simplify again. So times with the inner D into inside this. So 1.6 this inner D square minus 0.64 inner D plus 4.699 power of negative 3 is equal to 0. So by using the scientific calculator, by the equation EQN is more than degree 2, so we can determine what is the value for the inner diameter of D. So from the scientific calculator, the value of D is from the scientific calculator, we found that there is two value of D inner diameter, which is the first one is 392.518 millimeter, and then second one is 7.482 millimeter. So from these two value, we will need to choose one. So we choose the value of inner diameter is equal to 392.518 millimeter, because this value is more legit than compared to 7.482 millimeter, because this is too small. So from equation 1, we put the value back, the inner diameter of 392.518 millimeter into equation 1. So D, the major diameter, is equal to 800 power of negative 3 minus D, which is 800 millimeter minus with the 392.518 power negative 3. So we got the value for major diameter is 407.482 power of negative 3 meter, or 407.482 millimeter. So next, by using uniform wear theory, determine the actuating force required to engage the clutch. So uniform wear con clutch for actuating force. So we'll try to find what is the value of actuating force FA by using the uniform wear con clutch. So FA is equal to 1 over 2 times with the pi P max is our maximum pressure, times with the inner diameter D, and then major minus the inner. So simplify, put the value half times with the pi times with the maximum pressure, which is 80 kilopascal, times with the inner diameter, the value that we obtained just before, which is 392.518, power negative 3 meter, then times with the major diameter, which is 407.482, power negative 3 meter, minus with the inner diameter, which is 392.518, power of negative 3 meter. So simplify, we get the value for actuating force is equal to 738.103 Newton. So next, for question C, using uniform wear theory, determine force weight, first weight, which is W for that friction binding. So let's assume this is our conclage, and then the distance of these wedges, which is W. So this is our first weight wedges, and then from here until here is our inner diameter, which is D, and then from outer above to outer below is our major diameter. And then let's assume on this section, so assume there is a triangle here. So this is the triangle of the first weight. So the angle of the conclage, which is alpha is equal to 12.5 degree, and then the distance here is our first weight W, and then the vertical distance here we assume as D minus with D divided by 2. So from the triangle, we know that sine 12.5 degree is equal to the major minus the inner divided by 2 divided by the first weight. So simplify, our first weight is equal to the major minus the inner divided by 2 divided by sine 12.5, which is our alpha. So the value of the major we got from the Febre's calculation is 407.482 power negative 3 meter minus the inner diameter, which is 392.518 power negative 3 meter, divided by 2, and then divided by sine alpha, which is sine 12.5 degree. So simplify, we get the value for first weight W is equal to 34.596 power negative 3 meter, or in millimeter is 34.569 millimeter. So the next question, based on uniform wear theory, why semicon frequently designed as 12.5 degree? Give two reasons. First, to provide enough normal force to produce required friction force for efficient power transmission. Second, to ease dislodge of the clutch.